Welcome to the tutorial from KeMixTree. Today we have some problem to talk about in AB chemistry. And the problem here that we going to consider, the first one is how to write the expression for equilibrium constant, and the second thing is how to calculate pH from the molar concentration. Came from an AB chemistry, a free response question. We are having an equation here. The reaction of Methanoic acid, some people call this either formic acid. Formic acid react with water. Yeah, we are reacting with water to create the hydronium ion and formate ion. We have two questions here. The first one is about the expression, and the second one is how to calculate the pH. So these questions are very easy to solve, but some students may mistake. We're going to take the first one. The first one is how to write the expression. In order to write the expression for the equilibrium constant like this, we are having Ka. In order to write the expression, we're going to take a division of the product. Yeah, now I'm gonna write product here. Product divided by the reactant. We have to be careful because they are in different state. We have seen in the reaction here, they are in aqueous, but except the water is in the liquid state. So everything that was listed in liquid state or in solid state should not be written in the expression for equilibrium constant. Here we are going to have hydronium ion, the concentration of hydronium ion, the concentration of formate ion divided by formic acid. Yeah. During the reaction, the concentration of water are remaining the same, so we don't take water into account into the expression. Now we come to the next question. The next question that we have is how to calculate the pH of 0.5 molar solution of formic acid. In order to calculate the pH, we have to remember the formula of the pH. So we are having pH equal negative log the concentration of proton. Some people will say that we are having hydronium ion here, and we can write hydronium ion instead of proton. Hydronium ion. Okay. The second thing is we have to calculate. We have to know how much concentration hydronium ion is. So we have to take a step and calculate the concentration of hydronium ion. In order to calculate, we're going to write the reaction once again like this. Oh, hydronium ion here. Then we're going to take an ice box. Yeah, we're going to take an ice box here. This is a very simple technique to solve this problem. I is stand for initial, yeah. C is stand for change, and E is stand for equilibrium. The concentration of formic acid at the beginning is 0.25. So during the reaction, we don't know how much formic acid will go into the reaction. So we are going to put X here during the reaction, the formic acid will take up X concentration. Yeah. And during the reaction, we are going to create the equivalent amount of hydronium ion. And the same for formic ion. Finally, at equilibrium state, we are having 0.25 minus X. X here and X for this position here like this. In the previous section, we are having the Ka. We having the Ka here, so in order to calculate the concentration of X, we are going to put every number that we have found here. Yeah, every number that we have found here at equilibrium state into the Ka. Yeah, we're going to doing that right now. Ka here is equal to hydronium ion. Now we're going to take a look back. We take a look. Hydronium ion is X. Yeah. X time formic ion. The formic ion is also X. We come back here, write the X here, divided by the concentration of formic acid is 0.25 minus X. 0.25 minus X. We are having Ka equal 1.8 times 10 power to negative 4. 1.8 times 10 power to negative 4. So at final calculation, we're having the value of X. X is equal to 6.612 times 10 power to negative 3. And this is the value of X. We have the value of X, and the value of X is stand for the concentration of hydronium ion here. Finally, we're going to take some calculation. And then we get the value of pH equal to 2.18. And this is the final answer that we can get from this problem. And finally, this is the tutorial from chemistry, and see you in the next video.